All right, so far we've used sign charts to solve some inequalities. Now we want to use sign charts to help us come up with the sketch of a graph of a function. So let's say we have this equation, y equals x plus 3 times x minus 5. Now we know a lot about it. It's quadratic. It's going to be a parabola, all of that sort of stuff. But how can we use a sign chart to help us come up with that graph? First thing is to identify our two most important points. Those are going to happen at -3 and 5 because those are the zeros of this function. And we know that zeros of the function are actually x-intercepts. As we continue with our sign chart, we pick a number that's smaller than -3, like -1 billion, and test it out in our product. -1 billion plus 3 is negative. -1 billion minus 5 is negative. So we'll take a negative times a negative and come up with a positive number. When we pick a number in between -3 and 5, like 0, 0 plus 3 is positive, 0 minus 5 is still negative, so that product will be negative. And then when we pick something positive, like a billion plus 3 is positive, billion minus 5 positive, so the entire product is positive. And there we have our sign chart. Like I said before, we were using this to solve inequalities, and now we want to use it to come up with a graph. To do that, let's treat our sign chart, the line, as the x-axis. Then that's going to mean our y-axis would be about right here. Now, we already have our two x-intercepts happening at -3 and +5. Since this is a polynomial, we know polynomials are always smooth and continuous. On the first interval, the part where the x-coordinate is going to be less than -3, we see that every value is positive. And we know that it's going to just keep going up and up and up here. In that middle interval between -3 and +5, we know that the values are all negative. But we have to connect our two x-intercepts. So our graph is going to be negative, meaning it'll be below the x-axis, so down here, but connecting our two x-intercepts. After that, our graph is going to be positive, so it goes up like this. And we get that parabola that we were expecting. So what if we have a different type of polynomial, like y equals x squared times x minus 7? Again, we're going to create our sign chart first by identifying our two most important points. Those happen at 0 and at 7. Then we test each interval. If I take something extraordinarily negative, -1 billion, well, -1 billion is negative, but we're going to square that. Right? So that x squared is always going to be positive. Then -1 billion minus 7, that's negative as well. Positive times negative is negative. In between 0 and 7, well, if we pick a number like 1, 1 is now positive, but when we square it, it's still positive. So as we passed over that 0, at 0, we see that the factor didn't change sign because it was squared. It always stayed positive. But 1 minus 7 is still negative, so positive times negative is negative. Then when we pick something extraordinarily positive, we square it, it's positive. 1 billion minus 7 is positive, so the entire product is positive. Now, how are we going to graph this? We have our two x-intercepts at 0 and 7. Those were our two most important points. For every x value that's smaller than 0, our function is negative. So it'll be below the x-axis, like this. Between 0 and 7, that's also negative, but we have to connect two zeros. So we'll stay below the x-axis and connect our two zeros. After that, the function turns positive, so it'll increase. And we get this familiar S shape that comes with all cubic functions, but we notice that that 1 0 at x squared, that's a double zero, and to the left and to the right of that 0, our function stays below the x-axis. Now, when it comes to a rational function, we got to be a little bit more careful, but we are still going to create a sign chart. We have a most important number. It happens at 2. But 2 does not make this function equal to 0 because it makes that factor of x minus 2 equal to 0, but that's in the denominator. So That'll actually be a vertical asymptote happening at 2. We also know that when we're dealing with rational functions that if the degree of our numerator is smaller than the degree of our denominator, like it is here, then we'll have a horizontal asymptote on the x-axis. So here we have our 2 asymptotes. Now we can go ahead and test each interval, creating our sign chart. If I pick a number that's smaller than 2, like 0, 1 over 0 minus 2 is going to be negative. And as we pass over 2, then x plus 2 becomes positive, and 1 over a positive number is positive. Now we're ready to come up with our graphs. Right? We already have our asymptotes there. Those are going to be the boundaries of our graph as we get out towards the extremes. We know that on the first interval, for x's being less than 2, our sign chart says that the graph is negative, so it's going to stay below the x-axis and approach each of these asymptotes. And so we get this branch of our hyperbola. As we pass over x equal to 2, and we're on the right side of it, now our graph is positive, so it's going to stay above the x-axis, and again, approach each of our asymptotes. So we end up with our familiar graph that looks like this. Here's one that looks fairly complicated. Y equals x minus 1 over the quantity x plus 2 squared. We're going to create our sign chart and then come up with a graph from that. To create our sign chart, we need to identify our 2 most important points. They're going to happen at -2 and at 1. Now this is where it's really important to recognize why are those the important points. Now 1 is an important point because 1 minus 1 gives us 0 in the numerator, and we'll end up with 9 in the denominator. So that is a 0 of the function. Now, with -2, if we plug that in, we'll get -3 in the numerator and 0 squared in the denominator. So that's undefined, meaning that at -2, we have at least a whole, but holes only will happen if we are able to cancel factors. Since we're not canceling factors, this is actually going to be a vertical asymptote again. Now, as we come up with our sign chart, we're going to pick a number that's extraordinarily negative, -1 billion. -1 billion minus 1 is negative. And then -1 billion plus 2 is negative, but we're going to square that. So we see that our denominator will always be positive. Negative over positive is negative. As we pick a number in between -2 and 1, like 0, 0 minus 1 is negative, 0 plus 2 is now positive, but squared is positive. So that entire fraction will also be negative. Finally, we pick a number that's larger than 1, like a billion minus 1 is positive, billion plus 2 is positive, squared is positive. So positive divided by positive is positive. And this is what our sign chart looks like. We also can see that when we look at the numerator and the denominator, the degree of the numerator is 1. The degree of the denominator, since we're going to square this thing, is going to be 2. So we have the degree of the numerator being smaller than the degree of the denominator, which means horizontal asymptote, that is the x-axis. All right, now how do we graph this? Take it one interval at a time. On that first interval, when x is less than -2, we're going to stay below the x-axis and approach each of our asymptotes. So from here over to here. On the next interval, we're going to go from an asymptote over to a 0, and our graph is going to be negative. So it'll be below the x-axis. So it'll be like this. On the interval that's greater than 1, it has to be positive. So we get to cross over our x-axis. We're going to curve here. Going to cross over. However, we do still have this asymptote, which means as x approaches infinity, we have to get closer to that asymptote. So we'll have a curve that comes up above the x-axis for a little bit, then approaches the x-axis rather quickly. All right, here we got one that looks pretty intimidating. In fact, even when we start looking at it, it looks like it's all ready to go. However, we still got this thing that needs factored. So we got to continue, factor it a little bit more, and we'll have x plus 3, x minus 3. times x minus 1, all in the numerator. And in the denominator, we'll have x minus 2 squared times x plus 4 squared. So, to create our sign chart, we're going to identify those most important numbers. And it looks like our smallest one would be negative 4. Then we'll have a negative 3, positive 1, positive 2, and positive 3. So a lot of numbers to pay attention to. And all of those roots that come from the numerator, the negative 3, positive 3, and positive 1, those are all going to be zeros. And the two roots that come from our denominator, 2 and negative 4, those are going to be asymptotes. All right, next we got to come up with the signs. So we're going to start on that left interval when x is smaller than negative 4, and pick a number, like negative a billion. Negative a billion plus 3 is negative. Negative a billion minus 3, negative. Negative a billion minus 1, negative. Negative a billion minus 2 squared, so since this thing is squared, that will always be positive. And same thing on that x plus 4, that's squared, always positive. So it looks like we have an odd number of negatives, which means our entire function will be negative. In between negative 4 and 3, negative 4 and negative 3, we pass over that negative 4. So the sign of x minus 4 will change from negative to positive. However, we're squaring this, so that's always going to stay positive, which means the sign of our function has not changed, still negative. As we pass over negative 3, it's that factor of x plus 3 now that changes from negative to positive. Now we have an even number of negatives, so on this interval, everything is positive. As we pass over 1, x minus 1 changes from negative to positive, making the entire fraction negative. As we pass over 2, it is x minus 2 that will change from negative to positive. However, it's squared, so stays positive, and the entire function stays negative. After 3, it's x minus 3 that changes from negative to positive. Now everything is positive. Now we're almost ready to come up with the graph. We need to check the degree of the numerator and the denominator. And if we look in the numerator, we're going to have an x times an x times an x. That means that the degree of that is going to be 3. It'll be x to the third plus some. In the denominator, we got an x squared right here and another x squared. So x squared times x squared would be x to the fourth plus some for the rest of it. So we see that the degree of our numerator is smaller than the degree of our denominator, which means horizontal asymptote, that is the x-axis. And now we're ready to graph. So go over each interval. On the left side, it's negative, so our graph will be below the x-axis and approach each of our asymptotes. From negative 4 to 3, we're going from an asymptote to a 0 and staying negative, so being below the x-axis. In between negative 3 and positive 1 is positive, so we're going to be above the x-axis but connecting our two zeros. Between 1 and 2, negative, going from a 0 over to an asymptote, and staying negative below the x-axis. Between 2 and 3, staying negative below the x-axis, going from an asymptote to a 0. And then after 3, we're going to be positive, so we get to go above the x-axis, and we have to approach this asymptote. So it'll come back down and approach that asymptote. And there we have a really good graph, at least a really good sketch of the graph of this function. As far as how high those maximums are, that's what the details that we don't really have right now. If you wanted a more accurate graph, just plot some points. The more points you plot, the more accurate your graph will be.